Okay, so now I'm back. So we had x squared plus 6x on the left side, constant term on the right side. We're trying to solve for all the roots for this equation using completing the square. So the next step for completing the square, since x squared is a 1x squared, you're going to look at this middle term's coefficient, the coefficient of x, which is 6. So the number that we're going to add that's going to force this thing to be a perfect square is going to be half that number. So half of 6, and then we're going to square that. So half of 6 is 3, so we're going to add 3 squared. Now if I add 3 squared to the left-hand side, I have to do the same thing to the right-hand side in order to keep this in balance. So this is like the magic number that's going to make all this happen for us. Now what that is then, and you could rewrite it this way if you like, and then 3 plus 3 squared is 9, and 3 is going to give me 12. This thing that's on the left-hand side here, that's now a perfect square trinomial, which factors into the same factor, x plus 3 times x plus 3, or x plus 3 quantity squared. And it still equals 12. And then that's just like the problem that we just went through. You can take the square root of both sides, and if you take the square root of both sides, don't forget the plus and minus. So I have x plus 3 equals plus or minus. Well, square root of 12 is 2 root 3, so we'll write it that way, simplified. And then get x by itself by subtracting 3. So this particular quadratic has two irrational roots there, numbers that are not going to simplify and get rid of that radical there. All right, if you look at the next one, it's the same type of problem that we're going to go through and do, completing the square. There's one thing that's different with this one, and that's that 4, that's that coefficient there. So we'll start out, we'll get the 17 on the other side. Keep the 4x squared and the minus 20x on the left, 17 on the right, so it's negative 17. Now the part that's different is I have to get rid of that 4. So I'm going to factor a 4 out of this x squared and this 20x. And I can get rid of that 4. I can divide both sides by 4. Cancel over here. So I have x squared minus 5x. And don't worry about this negative 17 fourths. And if you don't like fractions, it's okay. It's going to end up simplifying pretty nicely for us. So if you go back to this left-hand side, we need the number that's going to complete the square. That's this thing that we just did back here. So it's 1/2 of that middle term's coefficient, which is 5. It's negative 5, but we're going to end up squaring it, so it becomes positive 5. So you can disregard the negative sign there. So half of 5 is 5/2, and then I need to square 5/2. That's the number that's going to complete the square. So I'll have 5/2 squared, 25 fourths. If I add 25 fourths to the left-hand side, I'm going to add 25 fourths to the right-hand side. This number that you put on the end here is always going to be a plus. It's always going to be added to the factor there. All right, and then we're back here ready to write this in factored form. So this is always going to factor into the square root of this first term, which is x, the symbol from the middle term, which is a minus, and then the square root of this number we just added on here, which is 25 fourths. Its square root is the 5/2 that we have back here, quantity squared. And then I have 25 minus 17 on this side. What's that going to give us? It's not 16. It's going to be 18 over 4. Or 8 over 4. There you go, 8 over 4. And 8 over 4 is 2. All right, and then again, you're doing the square root of both sides. Don't forget plus minus. So x minus 5/2 equals plus or minus root 2. And then again, get the x by itself. So 5/2 plus or minus root 2. You can leave it just like that. So completing the square. All right, and then the last example is quadratic formula. We've done lots of quadratic formula there. Remember, you want this in that descending order here. Let's find a fun color here. Oh, that's a good one. All right, so here we go. This is not in set equal to 0 in general form. So we'll rewrite it. 3x squared minus 6x minus 5 equals 0. So my value for a is 3, b is negative 6, c is negative 5. and then plug it into that quadratic formula there. X equals negative b, so positive 6, plus or minus the square root of negative 6 squared. This first number is always going to end up being positive because we square it. Minus 4 times a times c, all over 2 times a. Right, and then inside here, 6 squared is 36. And then what do I have? 20 times 3 is going to be plus 60, all over 6. What do I have there? 96, all over 6. And then the square root of 96. Let's see what that's going to simplify to. 3 will go into that. Be 32. 16, 2. So it's going to be 16 times 6. So this is going to give me 6 plus or minus 4 root 6 all over 6. And finally, I can reduce the 6 and the 4 and the 6. They all have a 2 in common. So if I divide by a 2 there, I'll have a 2 root 6 and a 3. All right, it's a quadratic formula there.